G'day, it's Richard. Type of video for you today. I'm going to challenge you to come up with an investigation and then collaborate with others by sharing your successes and or failures or questions with other people in the comments section beneath this video. So the challenge will be this. There's going to be a phone on an inclined plane or a slope, and your task will be to determine the relationship between the inclined plane and the friction that the phone will experience. Now, when you design your investigation, you're going to have to consider a number of questions. So we're looking at friction. So what you'll be having to answer a question such as, what is your hypothesis? Is it going to be that the angle of the incline will determine the size of the frictional force, or is it going to be that static friction is greater than sliding friction? So you'll decide whatever hypothesis it is you're going to investigate. And then you're going to make a prediction based on that hypothesis. And that mention of static and sliding friction, you'll have to understand what each of those types of frictions are, so you do some investigation or research on that. You'll have to then determine what measurements you're going to make and how you're going to make them, what your dependent, independent variables will be, what equipment and instruments might you be using to collect this data, and how you're going to present the data and your final findings. So this is a suggestion. You're going to have your phone on a flat surface and then raise the phone up onto the incline. Now you'll need to know a few things about this phone. Well, the incline as well. You'll need to know what angle it's at. You'll need to know the mass of the phone. So either you could look up the mass of the phone online, the model of the phone, you'll be able to find the mass somewhere online, or you can use electronic balance. Now that mass is going to exert a downward weight force, and that weight force can be split into two components or resolved into two components. And these components will be perpendicular components. One will be parallel to the incline and sliding down the incline, and one will be perpendicular to the incline. That's the one we call the normal force. Okay, those three forces, if we look at them, you can see that the red and the green components will add together to give you the purple weight force. So when you're looking at it, you will be able to determine that the green force down the incline is equivalent to mg sine theta. Very good. But how are you going to work out that angle? Now you could just use a protractor, but you've probably used them in the laboratories before and you see they're not that accurate. You could use an app. Now I've just selected one app here, Slope Angle, which seems to work okay. Many phones have compasses built into their operating systems, and you can just use them as well. Now with this app, what you could do is put the phone flat on a surface, raise the surface, and as you raise it, it'll give you the angle for which it's tilted, and then you'll see the angle at which it begins to slide. That will give you some indication as to what the static friction could have been, because you'll know that the force down the incline, when it just exceeds the static friction force, it will be mg sine theta, and then from the mass, the angle and so forth, you can determine what the static friction might have been. But as I said, we're investigating a few other things. We're looking at the sliding friction once it does start to move. So how could you measure the force down the incline? Well, you could just use a spring balance. I wouldn't recommend it because it's not super accurate. But you could investigate what options there are in regards to apps on the phone. Now, I had a quick look around and have seen, just looking for free apps, Mobile Science Acceleration app will give you the acceleration down the incline, the velocity down the incline, and the distance down the incline in one graph. So that's one thing that you could use. You notice none of them say force. So if you've got the acceleration measured and you know the mass of your phone, you can then work out the force down the incline. Now, how is that force going to relate to the frictional force? So when the phone is sitting on the incline, there are those components down the incline and into the incline. There's always going to be a force opposing it, which is the frictional force. So what you'll have to do is think, what is that type of friction? What type of friction is it? Is it sliding? Is it static? Will it be a constant force? And what will be the net force down the incline when you consider both the component of the weight and the friction force? So what I'd do is I'd investigate as many different apps as you can. And I'll just mention one right now, which I think is quite a nice one. Lab 4 Physics is one whereby they generously offer you 45 days free use of the app. And what it does is it makes use of all of the sensors in your phone, one of which is an accelerometer. That'll give you a nice little graph in the X, Y and Z axes. So what I'd recommend you do is now stop watching the video, sit down, work out a plan for your investigation, start to conduct the investigation. Investigators will do a preliminary trials, see how it works, modify and so on. And then once you start the work, if you get stuck, pose a question in the comments below and we'll see if we can help by responding to that. Or if you have a success and determine friction forces on the incline, share your successes with others. So I'd really like a lot of comments down below so people can help each other. Okay, I'm hoping this works pretty well. Until next time, this is Richard Marr. See you later.